So I'm gonna try and give you guys like a real foundational like 2 minutes, and then after that first foundation of a, like just a couple paragraphs of information, then we'll get into like your question about that strontium, magnesium, barium, calcium thing. All right. So in glaze chemistry, what we're interested in doing is like kind of counting molecules and looking at ratios of numbers of molecules to each other. So when I'm looking to make a really durable glaze, I want it to have 7 molecules of alkaline earth flux for every 3 molecules of alkali flux. And let me explain what I mean by that. If you look on the very left-hand side of the periodic table, our very first column is lithium, sodium, potassium. And those are our fluxes that are alkali fluxes, and they're really powerful fluxes. They're very good at melting things, but they're also very, very reactive once they get into our glaze and once the glaze has been fired. So if we have too much alkali flux, our glaze can be like dissolved by dishwasher detergent and lemon juice and stuff like that. So we want 3 of those molecules for every 7 of the molecules that are just to the right. That's magnesium, calcium, strontium, and barium. Um, the most common one is calcium, which is why I said like just dump in some whiting to make that glaze a little bit more uh, durable. But then also calcium, these the yellow fluxes here, the alkaline earth fluxes, they affect the way that our colorants work. And calcium is most likely what's already in the Albany slip. So using calcium won't affect the way that your colors work, as opposed to like magnesium, strontium, and barium might change your colorants a little bit.
Right. Right.
Yeah, so then there's like a couple of other ratios that we really care about. We want to make sure that our silica to alumina ratio is like under 12 to 1 or so, around there. It can be a little bit over, but not too far over. And if we're talking about cone 6, we're going to be we're going to have a couple more ratios that we care about. But for the most part, the silica to alumina and the alkali to alkaline earth flux ratios are really important.
Whoops.
Oh, cool.
I know, this is a good one. I'm gonna have to copy this.
ptable.com. I love that. That's great.
Yeah.
So do you want to go ahead with that question you were just about to ask?
No, it was actually just it was just another. I was missing the calcium part. That's all.
I'm so sorry. Hopefully this was useful anyways.
It really was. It really
Okay.
was.
Super
For
useful.
sure.
Yeah,
Yeah.
3 to 7 is a new thing for me to think. I mean, I feel like that got jammed into my brain sometime, but I definitely did not hang on to it. So I appreciate that coming back.
If you look up, like, it's weird because we knew this thousands of years ago before we knew science things, right? Like if you look at really old glazes, the ones that were the most popular were 3 to 7. And like Albany slip by itself is 3 to 7. And that's one of the reasons it was so popular, is it was like super durable. You couldn't dissolve it off of things. And people just knew, they were like, oh, this glaze I can't dissolve off of stuff with acids and bases, and this glaze dissolves really easily. And the ones that couldn't be dissolved tend to be the more popular ones, like Albany slip.
Wow. Very cool, Ryan.